determine if each is a function or not. So to be a function, I have to look at the independent variable or the domain, which would be the x's, and I'm going to look at all the x's. So if I just look at the x's, notice the x's are being red to be the first number, the 4, 0, 6, and 2. Only I could write 4, 0, 6, and 2, but we like to write them in order, so we probably go 0, 2, 4, 6, not the order that came in, but numeric order. And notice, if none of the x's repeat, it doesn't even matter about the y's, and it goes to a y, it does make it a function. So this one is a function, and the range would be all the numbers in blue, which would be the 15, 35, 20, and 25, but I would write them in order like that for a range. This would be my domain, and this would be my range. Let's look at the second function. The second one would not pass the vertical line test, so I know it's not a function. If I draw a vertical line up and down through it, it would hit the line in 2 spots, so I know it's not a function. But the domain looks like to me it's all the numbers less than or equal to 5. And the range, even though I want to put all real numbers here because even though we can't see it, this is a graph where it would go to infinity and beyond, and the numbers would surge up, so my domain would be look like that. So here we go. Is this one a function, yes or no? I'm going to tell you right away by looking. See this 0 right here? It has 2 things that go to it, so I know the answer is no right off the bat, just by that one little part right there. However, the domain, this would be the 3, -3, and 0, which I wrote them in order. And the range would be, in a sense, the same. Now notice, I did not write down 3, 0 twice. 0 is the one that I have 2 answers to. I didn't write it down twice, and I didn't write the 0 down twice. You don't have to when you do these. So look at this next one. Is it a function? You see a 9, 0, 6, and 2. If I write them in order, 0, 2, 6, 9, notice numbers, none of the numbers repeated, so it is a function. And the range would simply be, oh, it's just -5. I'm going to go back a second and realize I'd already hit the number. It's just -5. They all equal -5, but it's still a function. Doesn't matter as long as the x's don't repeat. The y's can, but the x's cannot in order to be a function. We're at the independent variables were 0, 2, 6, 9, and the dependent one here was -5. Here, as I look up here, notice each of these mappings has one arrow leaving from it, so I know it is a function. And the domain would be the numbers -2, 0, 1, 2. And it doesn't matter that the -2 goes to the 1 twice. It doesn't look like I'm very good here in my drawing, but in this case. Now look here at the second one. Notice the number 10 appears twice. So if 10 appears twice, it is not a function. And the domain, notice the number only have 3 numbers for the domain, and there were 4 in the range. That automatically should tell me that it's not a function because I have more range values than domain. And the 10 did repeat. That's all you're looking for, basically, do the numbers repeat. All right? The x's repeat. Y's can, x's cannot. And here I just looked at past the vertical line test. If I look at here, all these dots, and it is a function because none of them are vertically on top of each other. And if I look at all the x values, it's -5 and -3. That's a 0, 2, 3, 5, 6, 7, and 8. I'm not sure there's a 6, I see. My graph's not real good. And my range would be the y values, the 0. Notice the y's repeated. There's one here at 5 and 3 of them at 6, but that doesn't matter. 1 at 7, 1 at 8, and there's actually 2 at 9. My graph's just not real great. So this is a function, and the domain would be the x values for each of these points, and the range would be the y values for each of those points.